Two-dimensional systems of equations, also known as a 2-by-2 system of equations, is really just two equations of two lines, like so. 1 over 6x minus 2 looks maybe something roughly like that. Right? What I like to do here is label the equations as a and b. That helps me keep track of them just a little bit easier. Y equals negative 1 over 2x plus 2 looks something like this, equation b over here. And what we're trying to find here when we solve a 2-by-2 system of equations is this point right here, the point of intersection, which in this case is going to be, sorry, not that, 6, negative 1. All right, if we go on to Desmos, we can see that point of intersection at 6, negative 1. So one viable way to solve a 2-by-2 system of equations is to graph both of these lines. Right? Whatever method or whatever means you like to graph lines, you can graph both of these lines and then locate their point of intersection, and that's going to be your answer. But there are ways to solve this algebraically without the use of graph paper and all those kinds of things. So let's take a look at that. So let's take a look at equation 2 here, or our system of equations, which says x plus y equals 10, 3x plus y equals 16. Now I like to label these equations as a and b. And that's just something for me to organize. If I take equation a, right, if we look at equation a, which says x plus y equals 10, and we, let's say subtract x from both sides, minus x. Y is equal to 10 minus x. Right, y is equal to 10 minus x. And this is coming from equation A. That means if we take equation B, which says 3x plus y equals 16, that means we can take the 3x plus y portion and replace the variable y with 10 minus x. This means that 3x plus 10 minus x is equal to 16. And what we see here is an equation which says 2x plus 10 is equal to 16. This is a fairly simple, but more importantly, solvable equation that will let us get a value for x. 2x is equal to 6 after we subtract 10 from both sides. Divide by 2, and that means x is equal to 3. So if x is equal to 3, that means equation A can be rewritten, and instead of x plus y equals 10, we could write equation A as 3 plus y equals 10, because we know that x is equal to 3 already. And that means solving for y is as simple as subtracting 3 from both sides. So that means y is equal to 7. So remember that the answer for a system of equations is an ordered pair. Right? Before, our ordered pair was equal to 6, negative 1. That's x, y. This one is equal to 3, 7. And this is called the substitution method, because we are taking one of these equations up here, solving it for either x or y. If we solved it and said that x is equal to 10 minus y, that means we could solve it in a similar way. But the point is that we are substituting the variable y for 10 minus x. Number 3 over here, if we take equation A let's say we get 8x plus 14y equals 4. And let's just say that we subtract 14y from both sides and get 8x equals 4 minus 14y. We divide by 8, and everything has got to be divided by 8. We're going to get x equals 1 over 2 minus 7 over 4y, something like this, right? The point is here that it's not very pleasant looking, right? It's got fractions, and we don't like to deal with fractions, especially if we don't have to. So let's start over. Right, what we're going to do here is something called the elimination method. Right, that is the elimination method. And what we're looking to do for the elimination method is multiply, or essentially add up these equations together. If we add up these equations together, kind of like long addition, we're going to get 2x plus 7y is equal to negative 6, right? Still not great. So let's do this. Keep equation A the same. And let's take equation B and multiply it by negative 2. Everything's got to get multiplied. If we're choosing to multiply, which you will be on the elimination method, everything must get multiplied by the same thing. Everything on a single equation, right? You can multiply something different on each equation, and most likely you will need to. But within each equation, everything has to get multiplied by the same thing. So what we're choosing here is to multiply everything in equation B by negative 2. That's going to create a negative 12x minus 14y equals negative 20. And what we're looking for here is that the y variable has a plus 14 on equation A and a negative 14 on equation B. And this is exactly what we're looking for. We're looking for the coefficient of x or y must be the same number with different signs, essentially opposite signs. Because take a look at what happens when we add these together, right? 8x plus 14y equals 4. Added to negative 12x minus 14y equals negative 20. Right, we're adding them long addition style, so make sure your x, y's, and numbers line up. That's negative 4x over here. That is a 0 over here, and 14y minus 14y. And that is on the other side of the equal sign, a negative 16. So notice that our equation here says negative 4x equals negative 16. This is an equation that can be solved by dividing negative 4 to both sides. So we get x is equal to positive 4. So if x is equal to positive 4, that means either equation A or B. Let's take equation A. 8x plus 14y equals 4. Plug into one of your original equations, right? Equation B got changed into this. We don't need to use that. You can go back to your original equation B if you want to, but I'm just going into equation A because it looks easier. Everything is positive here. So if x is equal to 4, that means we can take our value of x and substitute it in and end up with an equation, 32 plus 14y, not 114, sorry. 32 plus 14y is equal to 4. Subtract 32 from both sides. 14y is equal to negative 28. Divide by 14, and y is equal to negative 2. And this is our answer, 4, comma, negative 2, as an ordered pair. So again, the substitution method or the elimination method, both of them will work in all scenarios. Substitution may involve fractions if you really want to go that route, because in here there's no way to solve for x or y cleanly without fractions. And that's just the nature of this problem. So the elimination method will help you avoid fractions if you really want to. Thank you for